Dear friends, today we will discuss about electric dipole and its intensity at any point on axial line and equatorial line. So from today we will start the derivations of class 12. In this lecture I will discuss two derivations, each is 3 marks. Today 2 derivations we will discuss, and these two are also very important derivations. Okay, let's come. What is electric dipole? The electric dipole. Di means two. Di, tri, tetra. So here di means 2. So dipole. Pole means, you see here, actually not exactly pole, we will discuss about charge. So 2 charge. What is electric dipole? 2 charge. 2 charges equal in magnitude separated by a finite distance is called an electric dipole. Again I am repeating, electric dipole means 2 charges equal in magnitude separated by a finite distance is electric dipole. Similarly, another dipole you will also listen in 5th chapter, that is called magnetic dipole. Magnetic dipole, same thing. Electric dipole, what derivations, what we will read, the same thing I will also repeat in the magnetic dipole case. If this lecture will concentrate, you will understand it clearly, you will get double benefit, because the same thing again will be repeated with a little change in magnetic dipole in the 5th chapter. That one also will be clear. So this lecture has double benefit for you. Okay, now let's come. I told you the definition of dipole: 2 charges equal in magnitude, see here, plus q minus q, equal in magnitude q, opposite nature, plus minus, separated by finite distance, is called electric dipole. So now the question may come to your brain: how these 2 charges are separated by finite distance? Two unlike charges, they must attract each other. If they attract each other, they will come now towards each other, and in the middle they will neutralize. Now you are putting the question towards its practical possibility. Is it possible, or just we are reading in physics like this? So it is most possible in day-to-day life. What is not possible we will not discuss in physics, because physics is just the representation of the law of nature. So it is most possible. So if it is possible, where it is possible? Now let us come to the practical possibility of this, where actually this dipole is present in our day-to-day life. You come to one molecule, HCl, H plus, Cl minus. H is plus charge, Cl is minus charge, means plus E, this is minus E. So this one I replace with plus E charge, this one I replace with minus E charge. You see, 2 equal charges, opposite nature, there must be some separation, because H plus nucleus and Cl minus nucleus must be some distance separation between them. Their nucleus cannot coincide, there must be some distance of separation. So this is the electric dipole. In day-to-day life, our electric dipole means it's nothing but a molecule. You have read what is molecule in chemistry? Look, it is a molecule. Molecule is called electric dipole. But we are presenting this as minus q and plus q. But in practical life, it is a molecule. We present it symbolically like this, hiding the H plus and Cl minus. Now I think this type of question will not come to your brain. Why plus q and minus q are not attracting each other? I am giving another example also, will be clear. Let's come to H2O. O, H, H. H2O. You see here. O has minus 2 charge. H plus, this is plus. Minus 2 means minus 2E. This is plus E. This is plus E. It has some bond angle. but I am not bothered about the bond angle. Okay, you know that in chemistry, but I am not asking that one. So here 2 minus, here plus E plus E. Plus E plus E. What is the total charge? Plus 2E. Total charge is plus 2E. But where is the center of this positive charge? Just like the center of mass we have read in class 11th. Center of the positive charge is here. Plus 2E. Here is plus 2E. Here is minus 2E. Now you see the separation. I am just symbolically presenting it. You see, this is plus 2 minus 2E charge. Plus 2E charge separated by some distance. This is the distance of separation. This is called one electric dipole. So H2O molecule is one electric dipole. Now you will not ask the question why this minus 2E and plus 2E are not attracting each other. So don't keep in mind dipole means in air 1 plus Q, 1 minus Q exist like this freely. If they exist freely, they must attract each other. But dipole is not like that. Dipole is one molecule. Then now the question comes to mind, that means all molecules are dipole? No, it is also not like that. All molecules are not dipoles. I am giving one example, you see. Carbon dioxide, CO2 you see, plus 4, minus 2, minus 2. So minus 2, minus 2. Total charge is minus 4. Where is the center of the minus 4? This is the plus 4 center. Where is the center of the minus 4? It is also lie on the plus 4. It also lie on the plus 4. What happened here? Plus 4 and minus 4, they coincide each other. Is there any distance of separation? No. Can it be called as a dipole? No. So carbon dioxide is not an electric dipole. Water molecule is electric dipole. Hydrogen chloride is electric dipole. Then which molecule is dipole? Which molecule is non-dipole? That is up to you. Then you will see. I now give you 3 examples. Now this, I just gave you these examples to remove that doubt from your mind that why plus 2 minus 2 are not attracting each other, and also you will further not put the question against the practical possibility of electric dipole. Let's come to our part now. In electric dipole, dipole is called as ideal. We will call it the ideal dipole when Q tends to infinity, 2L tends to 0. Then the dipole is called ideal electric dipole, or also called as short dipole. Short, SHORT, or called as short dipole. Now come to the one quantity which will measure the dipole strength, dipole moment. Come to one quantity which will see the difference between the dipoles. Okay, what this quantity, what it measures, what is this? Dipole moment measures the strength of a dipole. It measures the strength of a dipole. What strength is measured? How it measures mathematically? Mathematically, dipole moment is defined as the product of magnitude of either charge, both charge magnitude same, I took either charge, and the distance of separation between them, Q into 12. This is the dipole moment, the product of magnitude of either charge and distance of separation between them. I took the distance separation, you see, minus Q plus Q. I am taking 2L distance of separation. Why I am taking 12? That you will realize when I will go to the derivations. Always you will use half of it. If you use half of it, always 12 half becomes L. It is easy to write for us. If now I take a 12, its half will be L by 2. It will be little difficult to write L by 2 always. So let's better take it to 12. The length of the dipole I am taking 12. Okay. So what is the dipole moment? Product of magnitude of either charge and distance of separation between them. This is the electric dipole moment, and qualitatively it determines the strength of the dipole. Okay. Is it scalar or vector? Charge is scalar, you know. But what about this 12? So it's a vector quantity. Because L is a vector, so it is a vector quantity. Dipole moment. If it is a vector, now the question is coming, where is its direction? Its direction is minus q2 plus q. Why? Why from minus q2 plus q? No answer, because it is also conventionally taken. This direction is also conventionally taken, so don't put any question why the dipole moment direction is from minus q2 plus q. Okay, so this is the dipole moment direction. Then what about the SI unit? SI unit we are discussing coulomb, and for this 12 obviously meter. Coulomb into meter, and accordingly CGS unit 2 times coulomb into centimeter, start coulomb into centimeter, start coulomb into centimeter, and half coulomb into centimeter. And then dimensional formula, you see charge, you know A1 T1, and what about the distance L1. So this is the dimensional formula. You complete now all address about dipole moment. Okay, then we will come to we will find the electric field intensity at any point on the axial line and equatorial line. We will come to the derivation part now. We will start the first derivation. Electric field intensity at any point on which line? Axial line. This is also called, remember, end on position. Remember this one. Any point on axial line is called end on position. What is axial line? The line joining the two charges is called axial line. This line is called axial line. I am extending to both sides. This line is called as axial line. This is the center of the dipole. This is A point. This is B point, and we will find the intensity at any point P. This is the dipole, total length is 12, so this length is L and this length is L. And we will find P is any point at how much distance? Let us take distance R. At a distance R. P is any point on the axial line at a distance R from the center of the dipole O. We will start the derivation like this. Okay. And I told you sometimes the question will come to find on end on position. End on position means any point on the axial line. This is the axial line. So what we do? Same thing. We will find for plus q charge first. Then we will find for minus q charge. Intensity is a vector quantity. We will write their direction. Then we will add them algebraically or vectorically. Obviously, vectorically we will add them, because intensity is a vector quantity. I have already told you. Simply now let's start. Due to which charge? Plus q charge. Very simple derivation. E1 vector you write. K Q. Due to plus q, see this is plus q charge. At this point we will find. So what is the distance here? P square. Where is the direction? This is plus q charge. Here we find. I have told you when positive charge is away, when negative charge towards. So as positive charge is away. Away means like this. So I can write this direction simply as I cap. Let's take this I cap. Just like x-axis you take I cap. No problem. Any direction you can mention. You can also mention it from B to P like this. Let's write I cap. It's a very simple presentation. Okay, so K Q, but what is this? This equal to, you see, B to P distance. You see, take it OP minus OB. This one has not symbol, so I split into. I now change into like this, OP minus OB. What is OP? You see, OP is what? R. What is OB? Is L. So I am writing R minus L square into I cap. Over, you can mention it like this, or this one is not required in your exam copy. You may not write this one in the exam copy. For your understanding I did. Then come to due to minus q charge. Due to q charge minus q charge. E2 vector kq, this is minus q. At this point we find from A to P. So this is Fp square. Minus q charge, this point we find. Charge is negative. Direction is away or towards? Obviously negative means towards. Towards this. At that time you just forget this plus q. Towards. So this is E2 vector. Towards minus q. Okay? You forget this one. Towards minus q. Direction is plus q. The direction is plus I cap or minus I cap? This is obviously minus I cap. And what about AP? You see AP. AP, I now split the AP. Because for AP there is no symbol. What will split? AO plus OP. Okay? AO plus what? OP. But OP is R and AO is L. L plus R. I am writing here R plus L whole square. Okay? This one you can write it like this. This is minus I cap. Don't forget to write direction. As we have given vector sign here, we have to write direction here. So this is about the E1 and E2. Let's add them vectorically. We'll add them, then we'll find the net intensity. So now net intensity E vector is equal to, now you see, net intensity E vector equal to E1 vector plus E2 vector. What is E1? KQ by R minus L whole square I cap. What is E2? KQ by R plus L whole square, here minus I cap. Now add them. Okay, so now you see, do mathematics here. Little mathematics we have to do. 1, this R plus L whole square, KQ I am taking common, this minus sign I got here, KQ. Now do take LCM, R square minus L square whole square. I did A plus B whole into A minus B. 10th class algebra, A square minus B square. Then here R plus L whole square minus R minus L whole square I cap. So what is the numerator? A plus B whole square minus A minus B whole square. If you don't know the formula, you can open it. But I know you already know this formula, 4AB. 4AB. So this is 4RL. R square minus L square whole square I cap. Now let us simplify this formula in terms of dipole moment. I will simplify for dipole moment. For dipole moment P, I need P is equal to 2QL. Just before I told you P is equal to 2QL. We will bring here 2QL. This 4 you split into 2. So K, this is Q, this is L. From this I am taking 1, 2. So what to remain here? K, Q. So this becomes P. Or let us split it. Let's do one more step. But let us do properly. Q, 2, R, L and 1, 2 here. I split it into, you see now. Okay. So what is the intensity now here? You see K, Q and 2 and L. 2QL, they become P. So what remain? K, 2 and R. K, 2, P, R. R square minus L square whole square. So this is I cap. This is the expression of the intensity due to an electric dipole at any point on the axial line. But only in exam the question will come to find for an ideal dipole or find for a short dipole. If for short dipole what to do here? For short dipole I have told you L tends to 0. 2L tends to 0. Means L tends to 0. For short dipole L very less than R. L is very less in comparison to R. So in that case L square can be neglected here. Just you see I am neglecting L square from the subtraction part. You see what happened? K 2PR by R to the power 4. So this is K 2P by R cube I cap. So this is the intensity due to an ideal electric dipole at any point on the axial line. Okay, K 2p by r cube by cap. This formula also you have to remember. One thing I want to tell you here, this is the final formula, but some, nowadays in derivations some 1 mark questions are always attached. So in our discuss what questions can attach here in the derivation. If the whole derivation will be of 2 mark, then 1 mark the question will be attached. What question it can attach here? 1 mark question. How E depends on R? E inversely proportional R cube. I am reminding you here. Intensity due to point charge. How E depends on R? E inverse proportional to R square. But in dipole, E inverse proportional to R cube. Remember this one. Now you see the graph. Question will ask about the graph. E versus R graph. Graph is like this. Is it clear? Inversely proportional graph. The question will ask to draw the graph between E versus R. Another question also it can ask. What is that question? Very important this one. You see here. Dipole moment. Where is the direction of dipole moment? Minus q to plus q. This is the direction of dipole moment. Along positive x-axis. I cap. Where is the direction of intensity? Resultant intensity always also I cap. This is the resultant intensity here. Also I cap. Means dipole moment and resultant intensity. You see both directions. Both are in the same direction. So what is the angle between them? Angle between dipole moment and intensity is 0. This can be also 1 mark question. Fill in the blank question. What is the angle between dipole moment and intensity at any point on the axial line of electric dipole? Answer is 0. Both are in the same direction. Okay, so this is about the first derivation of the 12th class. Like this, in 12th class there are total 95 derivations, but today we start the first derivation. Total was 95 derivation total. Okay, so don't worry, we will complete the 95 derivations very soon in this year. But here, this is the first derivation. Everybody will practice derivation. Practice this derivation from own memory. You will write this derivation repeatedly time and again, so that you will be able to understand. So now, next we will come to the next derivation. Next is equatorial line. We will find the intensity at any point on equatorial line, which is also called as broadside on position. Remember this one. Any point on equatorial line, minus q plus q. This is the total distance 12. At the middle there is center of the dipole. Equatorial line. This line is called axial line, I have told you. But what is equatorial line? This line is called equatorial line. This perpendicular bisector of the axial line which passes the middle in between, this is called equatorial line. The line which is perpendicular to the axial line and passes to the center of the dipole, it's called equatorial line. And any point on this equatorial line is called as, any point, let's take one point P, this is called as broadside on position. Any point is called broadside on position. Now we will find the intensity at this point. Let's do. Similarly, just take this distance R. P is any point on the equatorial line at a distance R from the center of the dipole. First we find for plus Q charge. Due to plus Q charge. Due to plus Q charge, first see U1 vector. This distance is equal for us. A, this is B. Due to plus Q charge, K, Q, same formula, K cube R square. From here is plus Q, here is the point. What is this? B, B square. And the direction is plus Q, means here it will be towards or away. As a positive charge, it will be most away. This direction will be here, direction will be away. So see here, this is the direction of U1 vector. Clear? So it is along it right, I am writing from B to P. Along BP. Why I am writing like this? Because there is no cap will come now. For which I am writing the symbol along BP. But what is this actually? KQ. You see this R, this is L, half of the distance. So what is this? R square plus L square root over. And its square is here. You see its square is here. So it will become R square plus L square. And along BP. This is the direction. Similarly, due to minus Q charge. Due to minus Q charge. You see. KQ minus Q is here. So this line. KQ by AP square. A to P. What is the direction? Minus Q at point P towards charge. Minus Q means here it will come towards. So this is which vector? P2 vector. See, along PA. Now understand? But what is AP? Similarly, R square plus L square. This is also same. This is a distance same. R square plus L square. This is E2 vector. Can you mark one thing in E1 vector magnitude and E2 vector magnitude? See these two are the same now. E1 vector magnitude is equal to E2 vector magnitude. Now we'll find the resultant. How we'll find the resultant? We can find the resultant in two ways. By component method we can do. By parallelogram law also we can do. Two vectors, they start from a common point. We can use also parallelogram. By two methods we can do. Let's do like our NCERT book. Okay, I'm doing by component method. It's little easy for you. Okay, so now see. So you do component method, then we have to resolve the vectors into rectangular components. Now let us resolve U1 vector resolve into components. You have done in class 11th division, component division you have done in class 11th. Okay, this angle you take theta, this L, this angle you take theta. If this is theta, then this angle is theta. Okay, then E1, the component which is in touch with angle, it is always cos. The component which is not touching with angle, it is always sine. This is easy to remember, we have done in class 11th. This is E2, if this angle is theta, this is also theta, this angle is also theta. Resolve E2 into component, so this side will be E2 cos theta and this side will be E2 what? Sin theta. Okay, E2 sin theta. This theta is not touching with this component, E2 sin theta. But E1 sin theta and E2 sin theta, these two components you see along this y-axis, both E1 and E2 are magnitude same, sin theta to cancel each other. You can write E1 sin theta and E2 sin theta cancel each other. Then which component only remain? Only cos component remain. E1 cos theta and E2 cos theta. So what is the resultant intensity? So E1 cos theta plus E2 cos theta. Which direction is that? This we can write as minus I cap. No problem, we can write it minus I cap. Or you can name it some different, something you can write it R or something or C or something. Along PC you can write it, but I am writing minus I cap. No problem. So this is to E1 cos theta. How this is to E1? In place of U2 I replace E1 because E1 and E2 are both in same in magnitude. So 2 what is E1? KQ by R square plus L square. Cos theta you now bring from the triangle. You see this is the triangle cos theta. Okay, cos theta is from this triangle. What is the cos theta? POB triangle you see only. Now see, you can see POB, you can see POA, but I am seeing only one triangle POB. Let us see. What is cos theta? Okay, we are telling OB by PB. So B by H. Okay, what is OB? L. What is PB? R square plus L square root over. To K 2QL R square plus L square of power 3 by 2. R square plus L square is 1 power, this is half power, become 3 by 2. But what is this 2QL? Dipole moment. Already we have discussed. So this is Kp by r square plus L square power 3 by 2 minus I cap, the resultant intensity at any point on the equatorial line due to an electric dipole. But as usual, how we do for short dipole? Now we will do this one. You know, for short dipole, always very less than r. So L square tends to 0. We neglect L square. So remove the L square from this. If I remove, then what happens? You see, it is now E vector equal to Kp by r cube. Direction is minus. This is the expression of intensity due to at any point on the equatorial line due to one ideal electric dipole or short electric dipole. This is about equatorial line. Okay, this derivation is now complete. We will discuss what questions again will be attached in this derivation. Question number 1, same thing. How E depends on R? E inverse to R cube. Now the graph E versus R. I will not draw the graph. How many times I will draw? Now you see the same graph. You can have to draw. Then you see here dipole moment direction minus q to plus q. Where is the dipole moment? Dipole moment is along positive x-axis. But where is the resultant intensity? You see minus I cap. Dipole moment is plus I cap. Intensity is minus I cap. So what is the angle between them now? The angle between them now is, see, 180 degree. Question will come in the exam to find the angle between dipole moment and electrical intensity at any point on equatorial line. So this is 180 degree. So this is about third question. Now you come. It's a very important one. You now see the expression of equatorial line. K by r cube. This is the expression of equatorial line. I am writing the expression of again axial line. K 2p by r cube. K 2p by r cube concentrate on only magnitude. If I tell you what is the ratio E axial to E equatorial. Question number 3. This is also one more question. Very important question. This is, remember, very important. E axial to E equatorial. What is the ratio of, question will come like, what is the ratio of electrical intensity at any point due to electric dipole on axial line to that of equatorial line for same distance from the center of the dipole? Means R is same. Then what is the answer? Now you divide them. It's very clear, very clearly visible the answer. What the answer is coming? 2:1. This is the answer. E axial to E equatorial. The ratio is 2:1. It's a very important question. Now you come to question number 4. See question number 4 now we'll discuss. When we discuss question number 4, you see minus q plus q. Here on axial line, where is the direction of intensity? Here, this is E axial. Dipole moment is along x-axis. Intensity is E axial along same direction of dipole moment. And here equatorial line. Here equatorial line. Where is the intensity here? You see, this is equatorial line. Here is the intensity. If I tell you to find E axial, suppose E axial and E equatorial. E axial vector dot product E equatorial vector. If dot product I will give, what about them? What is the angle between E axial and E equatorial for one dipole? The angle is now 180 degree. If 180 degree, you will use the dot product formula AB cos theta. So cos 180, so minus E axial into E equatorial. Or if it will give, if this one will give for same distance from the dipole to this side as well as to this side, you can write it also. E axial is 2 times E equatorial. You can write it minus 2 into E axial. 2 into This is 2 axial, this 2 axial, E axial square. Sorry, E equatorial square. This will be. Because E axial is twice of E equatorial, so this is 2 into E equatorial square. You can write it like this, E axial into equatorial. If the question will come, question number 5, what is the cross product? E axial cross E equatorial. If cross product will come, then what will do there? What the angle between them? 180 degree. If 180 degree, what is the cross product? That collinear vectors. Cross product is 0. This question will only give whether you know or not whatever the angle between E axial and E equatorial. The question is testing whether you know or don't know the answer, the angle between E axial and E equatorial. So remember, this diagram is very conceptual diagram. Dipole moment is here, E axial is there, but E equatorial will be opposite to the dipole moment. So this is about the intensity on axial line and intensity on equatorial line due to an electric dipole. Another thing, if the question will ask to find intensity at any point, suppose that point is not on axial, not on equatorial, this is the dipole, minus Q, plus Q, center O, L. If I tell you to find at any point, suppose take the point here, point is P, we are taking always, let's tell this distance as R, this is A point, this is B point. What to do in this case? How will find? Will write for plus Q? Will write for minus Q? No, will not do like this. What to do here? Now see, this is the direction of dipole moment, P vector. Here you do one thing. You reach this angle is theta. This is given. P is any point at a distance R, making an angle theta with a dipole moment. You are taking that one from the starting. Let's split the dipole into two parts. Dipole moment is divided into two components. This is P vector. Along theta, this component is P cos theta. Perpendicular to theta, this component is P sin theta. Understand? Dipole moment is resolved into two components, P cos theta and P sin theta. So this, now I split the dipole into two dipoles. I split your dipole into how many dipoles? Two dipoles. For this dipole, P point is on which line? Axial line. For this dipole, P point is on which line? For P sin theta dipole, the P point is on which line? Equatorial line. Okay. So for due to P cos theta, you can write due to P cos theta, where will be the direction of intensity? You know, when the axial line, intensity will be in the same direction of dipole moment. This E1 vector due to P cos theta. So due to P cos theta, E1 vector. Okay, so I am writing only magnitude here. K, what is the formula? 2P, but P means here P cos theta. 2P by RQ. From the starting I have taken short dipole. Okay, from the starting. K 2P cos theta by RQ. Due to P sin theta, E2 is what? K2, no 2 here. Why not 2? Because this is P sin theta. For P sin theta, this point is equatorial line. As equatorial line, only P sin theta. Your dipole moment is P sin theta by RQ. This is E2. But where is the direction of E2? If equatorial line, intensity and dipole moment, how much angle between them? 180 degree. So this is P sin theta, this is the dipole. So E2 vector 180 degree with P sin theta. But E1 same angle with P cos theta. Okay. So now what about these two? Both are perpendicular to each other. P cos theta, P sin theta are perpendicular. And so P cos theta E1 are parallel and P sin theta E2 anti-parallel line but same line. Okay. So they are also perpendicular to each other. So what is the net intensity? Resultant intensity when you will find U1 vector plus U2 vector. So now what you have to do here? How will you find the magnitude? Angle between them is 90 degree. So we have to use U1 square plus U2 square root over. So this square plus this square root over you have to do. So you can proceed doing the root over now. K 2p cos theta. So k by r cube. So 2p cos theta. Here it's square plus k p by r cube sin theta. So it's square root over. So k p cos theta, you can take common k by r cube, then p. What remains inside the root over? I am taking common, there is the square, again root over, so cancel, it will become k p by r cube. It will become 4 cos square theta plus sin square theta. Okay, if we solve it one step more, what will get? E vector magnitude is equal to k p by r cube become 3 cos square theta. 1 cos square theta I take it from here, so 1 cos square theta plus sin square theta become 1. So become 1. This is the intensity at any point due to electric dipole. Okay. Also you can find its direction u1 u2. So the resultant will be making some angle with them by using parallelogram law. This is the resultant intensity. Make some angle, suppose make some angle here, you take theta, you take beta. I am taking this angle beta here. You can find the angle beta is the direction of resultant intensity with u1. Then you can find also the angle tan beta. You are remember the formula q sin theta by p plus q cos theta. But here theta is 90 degree between u1 and u2, so you can write e2 by u1. So tan beta is equal to e2 by u1. Q sin theta by p plus q cos theta. But theta is 90 degree between u1 and u2. Theta is the angle between u1 and u2. Will take while using the formula. Okay, e2 by u1. Then you can put in that expression. Also, you can find the expression of tan beta. I am not proceeding further here. You can do so. This is about the intensity of dipole at intensity at any point due to electric dipole. But I am telling you one thing. The last derivation what I did first axial, then I did for equatorial, then I did for any point. Intensity at any point due to dipole is not mentioned in CBSE syllabus. So those who don't want to read this one, no problem. You may skip this one. So this is not in your CBSE syllabus. It's not mentioned. But first two derivations are very important. Also I told you some related questions to that. You must prepare and practice it properly.